Bismillah ar-Rahman ar-Rahim. Officially, we are starting our chapter number 1, that is the binary system and hexadecimal systems. Okay. Okay, for all those students who are new to computer science students, for all those, it is very important to understand the binary numbers. So, binary numbers are the basic building block of the computer. You know, computer totally depend upon the binary system as its मेन जो इसकी जो main circuitry है that works on the binary systems. Like we have the two numbers in the binary system that are ones and zeros, right? And with ones and zeros, we mean that we are just turning on something and we are just turning off something. With one mean that we have million of switches, and when we send one to one of the switch, it will turn on, and when we send zero to the switch, it will turn off the switch. So we can say that we have millions and millions of tiny switches which must be on and off position. This lends itself logically to the binary system. Okay. A switch is in on position can be represented by 1. A switch is in off position can be represented by 0. This is the basic thing that you have to remember. That if the number 1 is given to a switch, it must be turned on. When the number 0 is given, it is turned off. So you are quite familiar with the decimal system. In Cambridge, we also say it as a Danry system. It is known as a Danry system, okay? Danry system or decimal system are all those numbers which have the base 10, right? We say that the number which have the base 10 means that it has 10 numbers, start from the 0 and ends at 9. And all of the numbers in the Danry system are the combination of 0 to 9, all the numbers. Like if we have the number 10, it is a combination of 0 and 1, number 11 is a combination of 1, 1, and so on. So all the numbers which are represented by Danry, it is a combination of numbers from 0 to 9. This gave us a well-known heading of the unit tens, hundreds, thousands, and so on. We have read, na? Then we have 1 number, 10 number, 100, 1000, 10,000. And if we have represent these numbers with the power, we represent 10 with the power 0, it will represent 1, 10 with the power 1, it will represent number 10, 10 with the power 2, it will represent 100, 10 with the power 3000, 10 with the 4. Means that the power which is on the number 10 represent the number of zeros in it, right? The 10 mean the number we have 1 0, top in the 1 0. 10 with the number 2 mean the number 1 with the 2 zeros. 10 with the 3 mean 3 zeros. 10 with the 4 with the 4 zeros. So it is the basic understanding of representing the numbers. Okay, now we come toward the binary systems. Binary system is based on the number 2. This only it have two numbers, values 0 and 1, can be used in the system to represent each digit. Using the same methods as Danry, this gives us the heading of 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and 2 raised to power 3, and so on. A typical heading for the binary system with the 8 digit would be, like we have in the previous slide, we have started with the 10 raised to power 0. And you have to remember that any number that is represented with the power 0 is always equal to 1. That is a generic term, okay? If we are representing a number 2 raised to power 0, it will be 1. 2 raised to power 1, it will represent the number 2. 2 raised to power 2, it will represent number 4. 2 raised to power 3, it will represent number 8. 2 raised to power 4, number 16. And I would like that whoever is attending our lecture, it have to write down these tables on its notebook. Okay, if we're representing these things in binary numbers, like we have different numbers, 8 numbers. This is written as 1 1 1 0 1 1 1 and 0. This will be a typical binary numbers. Okay, now the problem arises when we are converting these numbers from binary to denary and from denary to binary and from this number to any other systems. So we have to know the method how we are going to change this system from one numbering system to another. So in this system, when we are converting from binary to denary, it is fairly straightforward to change a binary number into a denary system. Each time one appear in the column value is added to the total. For example, the binary number in the previous slide. In the previous slide, we are adding the number 2, number 4, number 8, 32, 64, and 128, and it will, when we are adding this number, it will become 238. And how we get this number 238? If I go back to the previous slide, now consider these things. We are putting this 0 over here. The first number will be represented over here, right? I may write it somewhere with the pen if I'm properly writing it. We are presenting 0 over here, 1 over here, 1 over here, 1 over here. Then again, this 0 will be over here. Then 1 over here, 1 over here, and 1 over here. So what we have to do, we have to include all those numbers and add all those numbers which have the one number. We have to consider the 1 over here and the numbers that are written on the top. That is the actual value of that number. And when we are considering this first one, it will represent the number 2, number 4, number 8. We are ignoring all those numbers which have the number 0, right? This number 0 is over here. We are ignoring it. We are not adding this number. And similarly, we are also not adding this number. We are adding this number 32, 64, and 128. Now all these numbers 128, 64, 32, 8, 4, and 2 are represented in the next slide. We have written these numbers and we are just adding all of these numbers, and by adding all those numbers we are getting the result 238. Okay, this will be the activity of our class, and I would like that all who are attending this lecture have to draw this table on their notebooks.